This video will be on the ideal gas law. You've likely already learned the other gas laws involving pressure, temperature, and volume. These all stem from the ideal gas law equation. But first, what is an ideal gas? An ideal gas is a theoretical gas that does not interact with other particles and takes up very little space in a container. As you have learned, protons and electrons will attract each other. Because all atoms contain these particles, no gas is exactly ideal. However, these interactions generally don't vary the numbers very much, so we can still use the formula to get a relatively close number. The equation for the ideal gas law is PV equals nRT. Let's go through what each of these means. P is for pressure. This will usually be given in atmospheres, but torr and millimeters of mercury, which are the same thing, sometimes show up. The V is for volume, which is just the volume of the container. N will be the total number of moles of gas. You might need to calculate this from the mass using its molar mass. T is temperature, and it will always be in Kelvin. Finally, R is a constant that is used to match the units of the variables. It will usually be 0.08206 liters times atmospheres divided by moles times Kelvin. However, if your pressure is given in torr or millimeter of mercury, you should use 62.36 liters times torr divided by moles Kelvin. This value might seem overwhelming at first, but all you need to do with it is plug it in for the R variable. Here are some useful tips for doing these problems. First of all is don't panic. These problems give you a lot of information all at once. Also, sometimes you'll end up with a paragraph because they put in a lot of useless words. All you need to do is plug in the numbers you know and solve for the variable that's missing. Second is that conditions do not change during these problems. These all occur at one point in time, and it won't have, for example, T1 and T2. Third is that you need to check your units before you start calculating anything, otherwise you'll most likely get a wrong answer. Lastly, if you don't have enough info, chances are you are needing to use a different gas law to solve the problem. Now let me do an example for you. 2 moles of gas are at STP in an airtight container. The problem is asking you for the volume. The first thing you should do is write the equation out and put in the variables you already know. We know the R value no matter what, and the N value of 2 moles is given in the problem. However, it also gives you the T and P values. Standard temperature and pressure means the gas has a temperature of 273.15 Kelvin and a pressure of 1 atmospheres. Plugging in these values allows us to solve for the variable V. Solving for V will get you 44.8 liters when rounded to the proper significant figures. You might have learned that 1 mole of gas is equal to 22.4 liters at STP. That relationship comes from this equation. Here's another example problem. This time, I want you to pause the video and try it yourself, so go ahead and do that. Alright, now that you've done that, I'll go over the answer. The question gives all variables except for N. Solving for N gives you 1.9 moles of fluorine gas. But make sure you look back at what the question wants because this isn't the answer. In order to find the mass, use the molar mass, which is 38 grams per mole for fluorine gas. In the end, you should get 72 grams of fluorine gas. This equation should be easy to master if you pluck out numbers from the equation instead of being overwhelmed by all the information they give you. Thanks for watching, and I hope this helped you.